This small red cube is called a cubic centimeter. That means that all of the edges of this cube are 1 centimeter long. It also means that the red cube takes up or occupies 1 cubic centimeter of space. And when we're talking about space, we're talking about volume. So the volume of this red cube is equal to 1 cubic centimeter of space. The cubic centimeter can be expressed in 3 different ways. First, you can spell out cubic centimeter as you see on the screen. A second way to write cubic centimeter is by using the expression cc, which is simply the first letter of both words. If you decide to go into the medical field as a doctor or a nurse, you may see cubic centimeter expressed as cc, although the abbreviation has become somewhat outdated. The third way we can write cubic centimeter is cm superscript 3. This is the expression of cubic centimeter that you will see most often in your science courses. The cm is short for centimeter, and the superscript 3, or what we would call in mathematics the exponent 3, means cubed. So we can call this expression a centimeter cubed, or a cubic centimeter. Volume is a measurement of 3-dimensional space, which is a little difficult for us to imagine in our mind. So let's do a quick procedure that will help us to understand what we mean when we talk about the volume of 1 cubic centimeter of space. The impression left in the Play-Doh would be a space with a volume of 1 cubic centimeter. Therefore, 1 cc of liquid should fill this space completely. To check this out, let's put a little food coloring in water and fill the syringe with 1 cc of the red liquid. Now let's take the 1 cc of water and place it in the depression that we formed in the Play-Doh. Remember, the depression has a volume of 1 cubic centimeter. So 1 cc of a liquid should fill the depression all the way to the top. The cubic centimeter is one of the most important units of volume in the study of chemistry. So you need to become very familiar with its approximate size and conversion factors for other units. One conversion factor that you really need to know is that the volume of 1 cubic centimeter is equal to the volume of 1 milliliter. So if you have a volume of 10 cubic centimeters, it will be equal to a volume of 10 milliliters. And if you have a volume of 50 cubic centimeters, it will equal a volume of 50 milliliters. So going back to our demonstration, how many milliliters of red water do we have in the depression we made in the Play-Doh? Well, the depression was made with a 1 cubic centimeter block, and the water has completely filled the volume of that depression. So we must have 1 milliliter of water, because there is a 1-to-1 conversion factor between the cubic centimeter and the milliliter. Now let's do another demonstration that will help us to remember this relationship. We pour in about 50 milliliters of water and then use a transfer pipette to add the last few drops. We want to get the bottom of the meniscus right on the 50 milliliter line. And now we take our 1 cubic centimeter block and drop it into the graduated cylinder. Let's see that again close up and in slow motion. Watch the change in the water level. The red arrow shows you where the bottom of the meniscus was before we added the red 1 cubic centimeter block. Note that the water level has risen exactly 1 milliliter. The 1 cubic centimeter red block takes up the space of 1 cubic centimeter. Therefore, the water that was in that space has to move, and we call it the displaced water. This volume of water has to move upward in the graduated cylinder. So if we measure the rise of the water, we are measuring the volume of the displaced water, which has to equal the volume of the red cube. And we know that the rise of the water is equal to the volume of 1 milliliter. Therefore, once again, we see that the volume of 1 cubic centimeter is equal to the volume of 1 milliliter.